All right, next up we have pyramids. So we can have a variety of different types of pyramids: triangular, square, we can have rectangular pyramid, hexagonal or hexagonal. I'm not exactly sure how to say that, but it really all just refers to the base of that pyramid. They all come up to a point directly above the center of that shape. That distance from the very peak down to the base is the straight up and down height. And just like a cone, it also has a slant height. That L stands for the slant height. That goes down the side of a right triangle that's actually built into the shape there. So we have the distance that's halfway across the base here as the bottom side of that triangle, the straight up and down height as the, let's call that the B, that's the A, and that would be the hypotenuse or the C in that right triangle. So that's always built in. The volume uses the straight up and down height, and the lateral area and surface area both use the slant height. Another subtlety to this equation, this base changes. So the B and the P, they don't change between these equations, but they're always referencing the same thing. They're always referencing the base. That capital B stands for the area of the base, which will change. So it kind of depends on what shape you have on the bottom, how you're going to find that. This lowercase p also is referencing the base, but we're talking about the perimeter of the base there. So that just involves adding up the sides of the base there. All right, here we're trying to find the surface area of this right square base pyramid. So we have a square base, which means all four of those sides have to be 10. We're looking for the surface area there. So we're going to do B plus 1/2 LP. I think I flipped the order of these, but really we're just going to add those together, so the order doesn't matter. That's the lateral area plus the base. So I'm going to find the area of the base first. That's length times width, because I have a rectangle. It's also a square, but it doesn't really matter. 10 times 10 tells me that the area of the base is 100, plus 1/2. L is the slant height, so that's going down from the peak, down the side of this pyramid, down that slope side. So that L, or the slant height, is 13. And then the P is the perimeter of the base, so that's 4 times the side length there, or 40. So I'm going to multiply those together, get 260. And then add that to the 100 from the base. Find that the total surface area there is 360. I don't have any units, so I'll just say units squared. All right, here we're looking for the volume of that triangular base pyramid. So the volume of any pyramid is 1/3 times the area of the base times the height. So the height there, that's just given to me. The height is going to be 64. The area of this base, so area of a triangle, is 1/2 base times height. If we were given 3 sides here, to decide which 2 sides to use, you're always really looking for that right angle. That's always connecting the height and the base of a triangle. So to find the area of the base, we're going to do 1/2. I'm going to call the 84 the base of that triangle, and the 71 the height of that triangle. So we multiply those together and find that the area of the triangle on the bottom, the area of the base, is 2,982. That is going to fill in for this capital B here. The volume is 1/3 the area of the base, which is the area of that triangle, 2,982, times the height, which is 64. I want to point out the similarity between that equation and this equation. They both have a base and they both have a height. This is talking about the base and height of the 2-dimensional base of that figure. This is talking about the 3-dimensional shape, the 2-dimensional base, the area of that 2-dimensional base, and the depth of that pyramid, how high up and down that goes. So this is talking about the 3D shape. This is talking all about the triangle base on the bottom. I just want to reference that because in triangular prisms, that pops back up. So we're going to multiply those 3 together to find that final volume. And get that has a volume of 63,616 feet cubed. All right, one more example. We have a hexagon as our base there. The volume formula doesn't change. It's still 1/3 times capital B times H. That is the area of the base, and this is how we're going to find the area of that hexagon on the bottom. So we really only need one side there to use that equation. Really, that's all based on Pythagorean theorem. 3 times the square root of 3 divided by 2 times 0.8, the side length there, squared. It's going to tell me the area of that hexagon base. So when you square this and then multiply this stuff out, you get that the area of the base is 1.6627. I'm just going to leave it at the hundredths place. So the volume is 1/3 of that area, 1.66 times 3, which actually those are just going to cancel each other out. That guy and that guy just cancel each other out. So the final volume is 1.66 inches cubed. Just really want to stress that this equation works regardless of the base. As long as we can figure out the area of that base and we know the height, then you can find the volume.